everyone. I'm Sujani, faculty in physics at Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss the course description for applied physics. This is the course which is common for computer science and all its allied branches of engineering at the first year level. And I can confidently say that this course meets all the criteria of outcome-based education. So, before discussing about the course description, I'll just want to discuss what this outcome-based education is. So, let us look what the outcome-based education is. So, it is a very important and vital topic in our education process throughout the world. Therefore, it is very important to know about outcome-based education. Now, outcome-based education is a student-centric education process that focuses on what students can do or the abilities that they should develop after they are taught. Means here, the focus is not on what we teach, but on what the student learns. So, in a nutshell, if we put it, it is a student-centric approach. So, to understand OBE, we need to first understand what is outcome. Because when we say OBE, O stands for outcome, B is based, E for education. So, let us first understand what is this outcome. An outcome is what the learner will be able to do or perform as a result of some learning experience. Or an outcome of an education is what the student should be able to do at the end of the program or the course or the instructional units. That is what we call as outcome. Now, there are three types of outcomes. The first one is knowledge-based outcome, then skill-based outcome, and then attitude-based outcome. So, therefore, OBE should guarantee through its curriculum, teaching learning methodology, and assessment that all the three outcomes are attained. Means, whenever we are designing a course, so the outcome of the course has to be knowledge-based, skill-based, and also attitude-based. In order to take care of that, we need to focus on the curriculum, the teaching learning methodology, and the assessment should be framed in such a way that these outcomes are attained. Now, OBE includes what is important for the students to be able to do. So, I told you it is a student-centric approach. What the students will be able to do at the end of the course. So, under OBE, what we are doing, we organize the curriculum, instruction and assessment to make sure that this learning ultimately happens. So, whenever we are designing a course, keeping in mind the outcome-based education, so we organize the curriculum, instructions and assessments also so that the learning ultimately happens. Now, coming to the institute level, the institutions which adopt OBE, they try to bring in changes in the curriculum by dynamically adapting to the requirements of different stakeholders. So, when we are talking about stakeholders here, stakeholders are students, parents, industry personnel, and recruiters. So, for an institute, all these are stakeholders because they are scattering all these stakeholders. Means they have to keep in mind the requirements of the students, parents, industry, and also the recruiters. So, at the framing of the curriculum stage itself, the institutes will take the inputs or the requirements of different stakeholders and accordingly bring changes in the curriculum. So, OBE is all about feedback and outcome. So, they take the feedback from the Stakeholders, they make the changes and get the outcomes. Now coming to accreditation. What is accreditation? National Board of Accreditation is a board established by AICTE for the purpose of accrediting higher education institutes in India in the year 1994, and it operated as an autonomous body since 2010. And this NBA is mandatory for AICTE recognition from this year onwards, that is the academic year 2021-22. Means all colleges, all institutes who wants AICTE recognition, they have to go for NBA or National Board of Accreditation. Only when they are accredited, they will get the AICTE recognition. Now, if you see at the global level, Washington Accord is a multilateral agreement signed in the year 1989 between bodies that are responsible for accreditation and recognition. And now NBA is a full-time member of this Washington Accord since 2014. And NBA accredits program and not the institutes. So what do you mean by accrediting program and not the institutes? Now, if you see in an institute, we may have different programs. Like in our college, we have aero, mechanical, civil, electrical, electronics, computer science, and so on. We have different programs. Now, when NBA has to accredit, it will accredit only the program and not the institute. Means at the department level, each program head has to take care that their program is meeting the requirements of NBA and their program is accredited. So, before applying for NBA accreditation, the concerned department should make sure that their COs here means the course outcomes, are well defined and they serve the purpose of OBE, means the outcome based education. So, the first step is for the department to make sure that their COs are well defined, course outcomes are well defined and they serve the purpose of outcome based education. Now, what are the advantages of this accreditation? Why is it made mandatory by AICTE? International recognition and global employment opportunity. So, if a student passes out from a program which is accredited, then that program will have international recognition and global employment opportunities. That is the greatest advantage of this accreditation. Then more employable and innovative graduates with professional and soft skills, social responsibility and ethics. Here, more employable is the keyword. Students who are graduating from these programs which are accredited, because we are focusing on student-centric approach, what the student is able to do or perform at the end of the course. So that helps them to develop all these qualities. They will become innovative. They will have good professional and social skills, soft skills, and also these responsibilities and ethics towards the society. So all these will bring a holistic development in the individual after graduating from these programs. Next, better visibility and reputation of the technical institution among stakeholders. So we have already discussed who are the stakeholders. So if an institute has to be recognized, if it is an accredited program, there will be better visibility and reputation depending upon the ranking also. The visibility and the reputation of the technical institute will increase. So definitely the stakeholders will look for such programs or students from such programs for employment, or the parents would want to admit their wards in such reputed technical institutes. Next, improving the commitment and involvement of all the stakeholders. So when we said it is all about feedback and outcomes, so we are involving the stakeholders also. How are we involving the stakeholders? Suppose a parent or a student. First, we are seeing what is their requirement. What is the requirement of the student or the parent? Which programs are sought after? What are the courses they want to take? What electives they prefer? So the feedback is first taken and then the curriculum is framed. So when we are offering the same thing, it is very useful for the student as also as well as the parent. So we are involving the stakeholders. At the same time, we take the feedback from the industry and the recruiters. So what is the need of the industry at this point of time? So taking the feedback, the course is designed or the curriculum is designed in such a way that it meets the requirements of the industry too. So the commitment and involvement of the stakeholders is improving with this kind of approach. Then enabling the graduates in their profession and accomplish greater heights in their careers. So those who are graduating from these institutes which are accredited, they will accomplish greater heights in their career. They can build because I told you, they will be getting the holistic development. So they will excel in their careers. And also we prepare the students. Those programs will help them to attain leadership positions and challenge them and make them aware of the opportunities in the technology development. So they can go to very greater heights and achieve leadership positions. Many of them can become entrepreneurs. So because we will make them aware of the opportunities and the technology development. Next, what are the levels of OBE? There are 4 different levels of OBE. Very important to know. The first one is Program Educational Objective, which are called in short form as PEO. Second one is the Program Outcome, which we say PO. PO stands for Program Outcome. And the third one is Program Specific Outcome, PSO. The last one is CO, the Course Outcome. So we are going to discuss all the 4 in detail and understand what are program educational objectives, how are they important in outcome-based education. So one by one we are going to discuss now. So the first one is Program Educational Objective. So it is a promise by the department to the aspiring students about what they will achieve once they join the program. So before joining the program, the student can look, or the parent or all the stakeholders, they can look at the POs. They will understand what the department is promising. So with the help of that, the student can decide whether it is meeting his requirements or not. And POs are about professional and career accomplishment after 4 to 5 years of graduation. So when we say program educational objectives, we are keeping a long-term goal in mind. Means after 4 to 5 years of graduation, what the student will be able to accomplish. So that is how the PEOs are framed. Then PEOs can be written from different perspectives like career, technical competency and behavior, because we have seen different types of skills we are talking about. So all these things are kept in mind while framing the objectives. Then they are important for the prospective students who wants to join the program. So I told you that the prospective students can see the PEOs and understand very clearly what the program is going to offer them. Now the next one is program outcome. After the program objective, educational objective, comes the program outcome. These program outcomes are broad in scope and they tell us what the student will be able to do at the end of the program. And the POs are to be in line with the graduate attributes. So they have to be in line with the graduate attributes, and these graduate attributes are specified in the Washington Accord. I told you this is an agreement between the accrediting bodies to bring everything at a particular level or at the same level at the international level. So what they have decided is they are specifying some graduate attributes, and all our program outcomes have to be in line with the graduate attributes as specified by Washington Accord. And these program outcomes are specific, they are measurable and achievable. So whatever program outcomes we said, they have to be specific. There should not be any ambiguity. It is specific. So if I say a student who is joining in mechanical engineering will be very good at designing of machines, means it is specific. Then you should be able to measure. How are you able to measure whether it is able to design or not, or it is an achievable target or not? So all these things have to be kept in mind while framing the POs. Now, when we say NBA is a full-time member of this Washington Accord, so NBA has defined 12 program outcomes, and it is common for all the institutes in India. So if I'm talking about a graduate engineering program, so NBA has specified 12 POs, and these are common for all institutes. As I told you, to bring everything at the same level. And how will the students know about this? What is the program educational objective? What is the program outcome? What is the program offering us? How it will be known to the students? So in the syllabus book that is given to them, there will be a clear mention of the course objectives and the course outcomes along with COPO articulation matrix. So what is the COPO articulation matrix? So when I'm talking about a course, this course is in a particular program. So how is this course helping us to achieve the program outcomes? So how are they aligned? What is the relationship between them that is given by the course articulation matrix? This matrix helps us in mapping the COs with the POs, the course outcomes with the program outcomes. Now, as I told you, there are 12 program outcomes defined by NBA. So we'll just go through them. The first one is engineering knowledge, which has 3 vital features. So in each outcome, they have also mentioned the vital features. They are also very important in deciding our program outcomes. So the second one is problem analysis with 10 vital features. The next one is design and development of solutions, 10 vital features. The fourth one is conduct investigations of complex problems, 11 features. Then modern tool usage is the fifth PO, 1 vital feature. And engineer and society, 5 vital features. Environment and sustainability, 3 vital features. Ethics, 3 vital features. And individual and teamwork also is incorporated here, 12 vital features. And communication, 5. Project management and finance, 12 features. Lifelong learning, 8 vital features. So by this itself, you can understand how clearly these POs are defined. If you see, the first 5 are technical in nature: engineering knowledge, problem analysis, design development, conduct investigations, and modern tool usage. All these are technical, related to the course or the program. Now, if you see engineer and society, environment, sustainability, ethics, teamwork, communication, project management and finance, and lifelong learning, these are general in nature, which will try to bring the holistic development in the student. They are not only in learning the technical knowledge, but also gaining the professional as well as social, ethical skills by doing this program. Now coming to program-specific outcomes. What are program-specific outcomes? They are statements that describe what the graduates of a specific engineering program will do. So here I would like to give an example. If I am talking about program outcome, one outcome, the second outcome we have talked about is regarding the design and development. So if it is given as a general PO, design and development for an engineering program. Now, if it comes to mechanical engineers, what are they going to design? So for a specific engineering programs, they will be able to design a particular machine. Okay. If it comes to aero, maybe the PO will change for that particular, the design and development of an aeroplane, maybe. So it becomes specific for that particular engineering program. So we also talk about program specific outcomes. Even though we have generalized 12 POs, those 12 POs, how they are applicable to each particular or specific engineering program will be clearly stated in the program specific objective. In the program specific outcome. Now coming to the course outcome. Course outcome is a formal statement of what the students are expected to learn in the course. Okay. So where is this course comes from? Suppose if I am talking about a program. Okay. And then we have a specific program. And in a specific program, there are different levels. Suppose in engineering, we have first BTech, second BTech, third and fourth. 4-year engineering course it is. So in the first year or the first level, what are the courses they have? So suppose they have the basic foundation courses. They have math, they have physics, they have chemistry, they may have fundamental programming, whatever it is. So all these will become the courses. Now each course has to be aligned with the program. That is what we were talking about, the course outcome being aligned or mapped with the program outcome. So course outcome is a formal statement of what the students are expected to learn in that particular course. And this will help them to achieve that program outcome. And course outcome statements refer to specific knowledge, practical skills, area of development, attitudes, and higher order thinking skills that the students are expected to develop or learn during the course. Now, what are the characteristics of this outcome? What are the characteristics? They specify an action by the students or the learners that is observable. So first we should be able to observe by the students' action. So are we able to achieve that outcome or not? And they specify an action that is measurable. So we should be able to measure it also. And then they specify an action that is done by the students rather than the faculty members. If you see our traditional education, most of the times it is teacher-centric. Means if a curriculum is designed, if the teacher has delivered all the instructional units in that particular program, then it is the end of it. They are not going to discuss about whether the student understood it or whether the student is able to do it or not is not mentioned. They are only graded based on the grades. But here, emphasis is given on what the student will be able to do at the end of the program. So these are the important characteristics of these course outcomes. Now coming to Bloom's taxonomy, it's a very important thing which every student should know. So let us spend few minutes on understanding this Bloom's taxonomy. Benjamin Bloom, along with his collaborators, he published it in the year 1956, way back in 1956. And another person by name Anderson, he revised it in the year 2001. And what is this taxonomy is all about? Taxonomy means classification. Taxonomy, the word taxonomy, if you see the dictionary meaning, it means classification. What is it classifying? It is the classification of educational objectives. How do we classify the educational objectives? That was given by Bloom in the form of his taxonomy, which we call it as Bloom's taxonomy and later revised by Anderson. Now, Bloom gave a set of three hierarchical models which are used to classify the educational learning objectives. He used the three hierarchical models. Learning objectives are statements that describe what a student is expected to learn from the course. So when I'm talking about learning objectives, so what a learning objective tells about what the student is expected to learn from the course. Now, how we are going to use it? It is a tool by which one can measure the level of student's knowledge and at what ladder he exists. So we can assess the knowledge of the student and also know at which level he is. And by utilizing Bloom's taxonomy, students are not going to forget the information as soon as the class ends. Like in our traditional system, they are just not going to listen and forget, but they can retain and apply the information as they continue to grow as a student. So how do they retain? How do they apply? Makes a very important contribution for the growth of the student. And always they stay ahead in competition. When they are able to retain the information and apply the information, they always will stand ahead in any competition. Now, Bloom's taxonomy is considered as a global language for education. And it is frequently used by teachers in writing the course outcomes, as it provides a ready-made structure of and the list of action verbs. So teachers always use this Bloom's taxonomy to design or frame the course outcomes. Now, according to Bloom, learning takes place in three domains. Learning takes place in three domains. The first one is cognitive domain, which is always related to head. Next one is the affective domain, related to heart. And the third one is psychomotor domain, which we do with our hands. So all the three domains, the head, the heart and the hands, are being involved in the learning process. That is very important here. That is how Bloom's taxonomy has become very famous. So cognitive domain of learning is related to our brain. That is, our intellectual skills like thinking, reasoning, problem solving, all these require using our brain. So we call it as a cognitive domain. And affective domain is related to feelings, emotions, etc. So this domain takes care of all the other aspects of the learning, which are related to the heart or the feelings. And then there comes the psychomotor domain, which is related to motor skills. What we can do with our hands, what you can demonstrate, how do you apply the knowledge and create something. So all these three domains are taken care of. Now, if you see the levels in cognitive domain, first domain is the cognitive domain. How are we going to discuss about different levels? So in 1956, when Benjamin Bloom gave the taxonomy, this is the form in which he has put first base is the knowledge, then comprehension and application, analysis, synthesis and evaluation. So this is the hierarchical level he has given. So, and he is using the noun forms to relate that level. Knowledge is a level. It's a noun form. Like that. But in the year 2001, when Anderson revised this Bloom taxonomy, he changed them to the verb forms. Why verb forms? If it is in the verb form, it becomes very easy to measure because we said it has to be measurable. So, the knowledge has become remember, comprehension has become understand, application to apply, analysis to analyze, then evaluate and create. If you see here, these two are being swapped. Synthesis is becoming create and it is going to the topmost level, and evaluation is coming one notch below create. So evaluate and create. So this is the taxonomy which we are following right now. Let us briefly discuss about this also. So the stages which we are talking about here, they ascend in complexity. The verb form itself tells you how the complexity is increasing. Now first, the students need to simply remember the information provided to them. Means at this level, what they are doing, they are just simply remembering whatever we tell, whatever is delivered to them, they just try to remember. But reciting something does not mean they can demonstrate it or they have learnt it. It is only a memorization. With this, what we do is understand. Next comes the level understanding. So with understanding comes the ability to explain the ideas and the concepts. So if they are able to understand, they can clearly explain what the concept is or what their idea is. So the next step is they have to understand. They cannot simply be at the remember level. They have to understand what the concept says. And then they are challenged to apply the information and use it in new ways. So whatever information they know, they understand, and how do they apply it in different ways, in new ways. So this helps them to gain a deeper understanding of the material by demonstrating it and then moving forward. So these are the three stages we have discussed. At remember stage, they are able to simply recite. At the understanding level, they are able to understand what the concept speaks. And then the next level, they are going to apply that information. Now the next stage is analyze. So analyzing asks the students to examine the information in a new way. They are going to develop different skill now. They are able to analyze what the information says. They are able to know what the information is, examine, interpret the information. Then comes the evaluation. So evaluation demands the student to apprise the material in a new way and defend or argue against it as they determine. So here they are developing the skills of how do they defend what they have evaluated. Suppose if I say a student is using a particular semiconductor material, gallium arsenide. So I ask him, why are you using gallium arsenide? Why can't you use silicon here? So he should be able to defend or argue. When will he able to defend? When he knows about silicon, when he knows the information, he understands what silica does and where he can apply silica and where he can apply gallium arsenide. And when he can evaluate what is the benefit of this, only then he can defend or argue. So we have taken him to the level of evaluation. Then the final step in the revised taxonomy is creating. So which entails developing of new product. In creating, they try to develop a new product. With all the information and knowledge and application skills, analyzing and evaluating, they can go to the level of creation, creating some new products. So this is how the levels increase in their complexity. And with the help of this model, how we can increase the learning levels of the students. Now, when we see remember, understand and apply, they require lower order thinking skills. But when it comes to analyze, evaluate and create, they are higher order thinking skills, which we call it as HOTS. So with the higher order thinking skills or the questions which are HOTS we call, the analyzing, the evaluating and the creating skills will be developed in the students. Now let me just briefly tell you about this, because when I told you Bloom's taxonomy is used by teachers because it gives a ready-made list of verbs by which they can assess the students or they can measure what the student is able to do at the end of the program. And then we have discussed different levels. So in the remembering level, what we are trying to do is whether the student is able to recall, recognize or identify concepts. So for that we use the verbs like define, describe, label, list. All these kinds of verbs are used at this level. Then comes the understanding level, where we try to see whether the student is able to comprehend the meaning and explain what the concept is in his own words. So for that we use the verbs explain, illustrate, paraphrase, classify, summarize. All these verbs are used to test the understanding level of the subject. Then comes to applying. So here what we are doing, whether he is able to use or apply the knowledge in practice or in real life situations. So when a real life situation comes, whether he is able to apply his knowledge or not. So for that we use the verbs use, apply, execute, produce, construct, prepare. All these are the verbs that are used. And the next one is analyzing level. At analyzing, they will try to interpret the elements, structure the relationship between different components. So we use the verbs analyze, structure, compare, break down, quantify, examine, experiment, relate. All these terms are used at the analyzing level. Then comes to the evaluation level. So assess the effectiveness of the whole concept in relation to other variables. I gave you the example of evaluation here, gallium arsenide and silicon. So here, whole concept in relation to the other variables is being assessed. So assess, review, justify, defend, present, all these verbs are used at this level. Now coming to the highest level, that is creation, they will display creative thinking. We can see by the products they develop in a new way, we can see the creative thinking and the new concepts or the approaches. So for that we use the verbs develop, design, plan, create, synthesize, arrange, regenerate. All these terms are being used at the creation level. Now, if you see the entire OBE framework, outcome-based education framework, this is the block diagram I can say for that. So, the first block, it has at the institution level what we have, and at the program level and at the course level, what will be the outcomes. And for this, the initial input or the feedback comes from the stakeholders. Stakeholders are the parents, students, industry, alumni, and the professional organization. So first, if we take the institute will take the inputs from all the stakeholders and then try to frame the outcomes. And for a particular institution, we'll have a mission and a vision statements. And these two have to be aligned with the graduate attributes that are specified by NBA as mentioned in the Washington Accord. So this has to be taken care of at the institution level. Then comes the program objectives, program educational objectives, that is the POs and the POs, program outcomes. So at the department level, each department has to take care of their program outcomes. Then comes the course outcomes. So in a particular program at different levels, the students do different courses. What each course is offering has to be as per the Bloom's taxonomy, it has to be assessed. So this is the what is regarding the outcomes. Now, with this, if the institute is framing the curriculum as per the requirements and they have set a well-prepared educational objectives with the program outcomes, okay, and the program outcomes always have to be aligned with the graduate attributes, and all the courses are aligned or mapped with this particular program, then comes the teaching learning methodology. How are we delivering it to the students? Whatever is designed here, are we able to give it to the student and the student is able to learn it and demonstrate it? So for that we have different learning activities and the assessment tools. Tools to assess whether the student have learned it or not. And for effective learning, we have different methodologies and learning activities. So once the student has learned, then comes the assessment and evaluation. In this block, we have the assessment and evaluation. So the first one is the bottom level, that is a course assessment. So whatever they are doing courses, so we have set some course outcomes, means the student will be able to learn this and this. So here I am going to assess whether he has learned it or not. With the help of this assessment, I am going to see whether that particular course outcome is attained or not. whether we are able to meet it or not. Then comes the program assessment. So with the program assessment, all these course assessments are aligned with the program assessment. So if they are mapped properly, automatically, if the course outcomes are achieved, then the program outcomes will be attained. And then with this comes the institutional assessment. So whether the vision and mission of the institute is being met or not with all these things. That is how. And then once it is assessed, there is always a feedback process. So once they get the feedback, after whether they are attained, it is fine. If they are not being attained, what are the improvements that are to be done? Always there is a scope for improvement. So if they are doing good, they can do better. So with the inputs from the stakeholders and from the assessments, they can always improvise on these outcomes and then give it as an input again while framing the next program educational objectives. So this is the OBE framework. Now, when it comes to our institute, as the students of this institute, IARE, you should clearly know what is the vision and mission of our institute. So the vision means it's a long-term goal which we are talking about. Our mission is the path to which we try to attain this vision. So our vision is to bring forth professionally competent and socially sensible engineers, capable of working across cultures, meeting global standards ethically. So this is the vision of our institute. Then what is the mission to achieve this? So we are going to provide students with an extensive and exceptional education that prepares them to excel in their profession, guided by dynamic intellectual community, and be able to face the technically complex world with creative leadership qualities. So all this is being provided for the students so that they will become professionally competent and meet the global standards. So these two things have to be kept in mind for the vision, because ultimately what an institute is going to achieve or look at is the vision and mission of the institute. Now, when it comes to assessment planning, once the program outcomes are set and the course outcomes are there, so how do we assess whether they are being met or not? So what are the learning levels we have? We have 6 different learning levels: remembering, understanding, applying, analyzing, evaluating, and creating. So these first 4 levels, in fact the first 3, they are assessed with fixed hour examinations. Fixed hour examinations are our CIE, that is continuous internal evaluation, and semester and examinations. We have mid exams we call, or the continuous internal examinations, and also we have the examinations at the end of the semester. So these examinations will help us in checking whether or seeing whether our program outcomes are attained or not, course outcomes are attained or not. Then for the higher order thinking, like analyzing, evaluating, and creating, we use course projects, mini projects, major projects, or the full semester intern projects, where the student has to actually use all the knowledge and he has to analyze, evaluate, and create something new in a project. So these are assessed with the projects. So we call them as under project-based learning. Now coming to the theory course assessment under Bloom's taxonomy. So what are the levels what is the weightage we are allotting in different examinations? How we are going to check the assessment? Now in CIE 1, remembering level questions will be 30%, understanding 60%, and 10% applying level. When it comes to the second CIE, it is 30% remembering, 50% understanding, and 20% applying. We are trying to take them to a higher level from remembering to applying. And then we also have AAT, which we call it as alternate assessment tools. They are used to assess the higher order skills like analyzing, evaluating. So first they try to apply, analyze, and then evaluate. So AATs are used for this. And then the end semester examination, if you see, 20% only will be remembering questions, 40% understanding, 30 apply, and 10 analyze. So this is how the distribution is to check for the CO, PO attainment. Now when it comes to laboratory course, so we are not focusing on remembering and understanding level. So whatever they have learned in the theory, they start applying here. So 30% is applying level, 30 analyze, 20 evaluate, and 20 create. So even in practical, we have continuous assessment and also the end semester exam. So how we are differentiating between these two? At end semester exam, we are going to focus mainly on creation level. So what is the end product they are going to output? It is at the end of the course, what they are able to learn, that is majorly assessed here at the end semester exam. So major focus is on creating level. Now let us discuss the course description for this course, Applied Physics, based on the outcome-based education we have seen. And I said this is common for all the courses of computer science engineering, artificial intelligence and machine learning, data structures and computer cyber security, CSIT, and also IT. For all these courses, this course Applied Physics is common. Now, let us see the course overview. What is the overview of the course? What is the course offering? So, it is structured specifically to make the students understand the core topics in physics essential for further studies in engineering. So, we are not going to put the entire physics in the first year level or in this particular course. So, they have learned a lot of physics. They have done so much, learned in their plus 1 and plus 2 level. But here what the major focus is on, what is essential for further studies in engineering? What are the topics in physics which they have to learn the application part which will help them in engineering? The major focus is on that. And it also focuses on illustrating and developing an understanding of the interplay between problem solving and their practical applications. So with the help of experiments and using the modern equipment, they try to understand the practical applications of the knowledge. Then what are the topics we have? We have quantum mechanics, semiconductors, optoelectronic devices, magnetism, dielectric, laser, and fiber optics. So these are the topics that are included in this course. And then at the end, what happens? This course helps the students to appreciate the diverse real-time applications in technological fields in respective branches. So in various branches of engineering, how this course lays a strong foundation and helps them to understand the diverse applications. That is how it helps the students. So in the first one is the quantum mechanics, as I said. So these are the different topics. Introduction we have de Broglie hypothesis, wave particle duality, Davison and Germer experiment, time independent Schrodinger equation, physical significance, then Schrodinger wave equation applications for one-dimensional potential box. Then in the second module, that is Introduction to Solids and Semiconductors, first it is the understanding between the classical free electron theory and quantum theory, then Bloch theorem, then chronic penny model, then classification of materials into metals, semiconductors and insulators. Then in semiconductors, we are going to discuss different types, intrinsic and extrinsic semiconductors, derive expressions for their carrier concentration, and then understand the dependence of Fermi level on carrier concentration and temperature, and then the experiment, that is the Hall effect, which helps us to understand or calculate the charge carrier density. And the third one is semiconductor devices. In semiconductor devices, first we are going to understand what are direct and indirect band gaps. Then how a PN junction is formed, what are the characteristics, voltage current characteristics. Then understand the energy band diagram, biasing of a junction, why is a biasing required and how do we do the biasing, different types of biasing. Then Zener diode, construction and working of LEDs, photodetector, pin diode, that is PIN or the avalanche photodiode, and then the solar cell. Then in the fourth module, we have engineered electric and magnetic materials, where we study about polarization, different terms that are involved with this. We are not going to go deep into the subject, but what are the basics that are required, which will be used at different levels in engineering. That is what we are going to see here. Polarization, permittivity, dielectric constant, then internal field in solids. How is the internal field? Then Clausius-Mosatti equation, electronic, ionic and oriental polarization, ferroelectricity, magnetization, permeability, susceptibility, then classification of materials into para, dia and ferro on the basis of magnetic moment, and then finally the hysteresis curve. The fifth module, the last module, is laser and fiber optics. So in the first part, we'll see about laser. What are the characteristics of laser and the phenomena, spontaneous and stimulated emission, metastable state, the terms that are involved here. Metastable state, population inversion, lasing action. Then two different types of laser. One is the solid laser, that is ruby laser, and helium neon laser, which is a gas laser. And also understand the applications of laser in different fields. In the field where are we using this laser in medicine, in industry, and also in studies, different studies, how we are using this, we are going to understand. Then principle and construction of optical fiber, how optical fibers are made. Then acceptance angle and numerical aperture, which are very two important terms that are involved with optical fibers. How are we going to calculate these two things? And then types of optical fiber based on the mode of propagation and also based on the refractive index. Then the block diagram to understand how optical fiber communication takes place. And then finally we see the applications of optical fiber also. So this is the brief outline of the syllabus that we have in this course. Now coming to the course objectives. So what is it, the objective that we are going to achieve by giving this course? So when a teacher is framing this curriculum, so what is the objective? What the students are expected to learn? So the student will try to learn basic formulations in wave mechanics for the evolution of energy levels and quantization of energies for particle in a potential box with the help of mathematical descriptions. So with the help of mathematical descriptions, he is going to understand the evolution of energy levels, which helps in every field of engineering. Whenever they are dealing with materials, they need to know how quantization of energy takes place. And then the second one is, they will try to learn the fundamental properties of semiconductors, including band gap, charge carrier concentration, doping and transport mechanisms. Again, when it comes to branches of computer and electronics, all these things are very important. How carrier concentration takes place, what is doping, transport mechanisms. So all this is being achieved. And then third one is the metrics of optoelectronic components, laser, then optical fiber communication, and they should be able to incorporate them into the systems for optimal performance, how they can be used in different systems for optimal performance. Then the use of the appropriate magnetic and dielectric materials required for various engineering applications. So wherever we are talking about engineering applications, there may be materials, magnetic and dielectric materials. So they have to learn about them. So all these are the course objectives. Now coming to course outcome. As I clearly told you, outcome clearly tells us what the student is going to able to do at the end of the course. So now we have 5 different modules. So for 5 modules, we have 10 course outcomes, 2 for each module. So when it comes to the first module, so in the first course outcome, what we have, they should be able to outline the drawbacks of classical mechanics by doing experiments that reveal the dual nature of matter. Then in the second CO, the course outcome, what is mentioned here, they should make use of quantum mechanical description for simple systems by using Schrodinger's equation, like I have explained the potential box problem they do. Then the third one, CO3, talks about illustrate the charge transport mechanism in intrinsic and extrinsic semiconductors by quantizing the charge carrier density. Now, when I'm talking about the COs, the course outcome, I'm also mentioning the Bloom's taxonomy level, which level they are learning here. So when it comes to the first CO, they are just outlining the drawbacks, means it is at the understanding level. And the second outcome, if you see, they are making use of these descriptions and then they are applying it to with the help of Schrodinger wave equation. So we call it as apply level. And the third one is illustrate the charge transport mechanism, how it is happening, they are able to explain. So it is again at the understand level. So with each CO, which level it is we are able to understand. So if I'm talking about this CO, it is at the understand level. So if I'm giving something at this CO, for this CO means it is at the application level. So we are simultaneously looking at what is the outcome and which level it is. Now the fourth one is identify the nature of charge carriers in a semiconductor by using the phenomenon of Hall effect. So they have to identify, means they have to apply the knowledge that is required. Then summarize the detailed knowledge of the fundamental and applied aspects of optoelectronic devices in physics. So that is understand level. Then coming to CO6, apply the key concepts of semiconductors to explain basic working mechanism of optoelectronic devices, characteristics in light emitting diodes, photodetectors and solar cells. Again, it comes under the apply level. So what you have to understand is what is the CO, what is at particular level. So which module we are trying to assess at which level. Now coming to CO7, relate principles of different types of polarization mechanisms to the properties of functional ferroelectric materials. So it is understand level. They have to just relate, understand and relate. Then CO8, utilize spin and orbital motion of electrons in determining the magnetic properties of materials and their role in classification of magnetic materials having specific engineering applications. So what about these materials and where they are being used, how they are being used is application level. Next, CO9, compare the concepts of laser and normal light in terms of mechanism and working principles. For applications in various fields and scientific practices, it is at the understand level. Then the last one, CO10, explain the functionality of components in optical fiber communication system by using the basics of signal propagation, attenuation and dispersion. They are able to explain, means it is at the understand level. So like this, we have divided the entire course based on 10 outcomes. These are the 10 course outcomes which are to be achieved by the end of the course. Now, if we see the competency level of this course, knowledge competency level of this course, 60% is understanding level and 40% is apply level. So, as I told you, this is a foundation course for all branches of engineering. And when you see, what we are majorly focusing is they have to understand the concepts and know how do they apply them to their engineering field. So in the field of engineering, how they are going to apply, that is what they are learning at this stage. So the major focus is on these two levels. Now when it comes to the program outcome, when we have set the course outcomes have to help in achieving the program outcomes. So how the course outcomes are mapped with the program outcomes now. So the first program outcome, if you see, is engineering knowledge. So in engineering knowledge, we have apply the knowledge of math, science and engineering fundamentals and engineering specialization to the solution of a complex engineering problems. So here we are going to see, with the help of this subject or the course, we are seeing how this course can help them in attaining the engineering knowledge. And the strength here is 3. We are also talking about the strength of this outcome. And how the proficiency is being assessed is through continuous internal evaluations. We may have quiz and also the alternate assessment tools. Then this course is also going to contribute to the second PO, that is problem analysis. The second PO, the program outcome, is problem analysis. How this course is contributing to the second PO? By identifying, so whenever they are doing numericals or analytical questions they are doing here, they are able to identify, formulate, review, analyze the problem and reaching some solution or finding the answers. So that is how the PO2 is being attained. The strength is 2. And again, the proficiency is being assessed by continuous internal evaluations, quiz and AAT. And one more, that is PO4. PO4 is about conduct investigations of complex problems. When we say complex problems, means here use research-based knowledge and research methods, including design of experiments, analysis, interpretation of data, synthesis of information, and provide valid conclusions. So all this is being done, whatever they are going to learn with various experiments they are doing, be it the Hall effect experiment or the Davison and Germer experiment or the Newton's rings experiment. Through these experiments, they are able to understand how investigations are being conducted on complex problems. So this course is also contributing to PO4 and the strength is 1. And the proficiency is being assessed through AAT, alternate assessment tools. Now, when it comes to program specific outcome, I told you when it comes to program specific means with that particular program, I'm talking about computer science engineering and its allied branches. So what is their third program specific outcome is make use of modern computer tools for creating innovative career paths, to be an entrepreneur and desire for higher studies. This is their PSO. So whatever experiments we are doing in the laboratory under this course, that will help them to understand the modern tools and also how they will help them in developing doing the experiments using different tools and helps them to understand, have an understanding for their further studies. Now, how are we mapping the COs with POs? How do we map a course outcome with the program outcomes? So, when it comes to the 10 course outcomes, there are 10 course outcomes and there are 12 program outcomes. So, all the course outcomes we are talking about are related to knowledge of the concepts related to physics. So they all will meet the requirement of the first PO. So we have mapped it to all. And the second one is related to problem analysis. So our CO2, which is talking about calculating the potential energy levels. How do we quantize the energy levels, calculate the energy at different levels? So we have mapped it here. And also the fourth one we have mapped because there are problems. Wherever there are problem analysis, we have mapped them to the second program. Third is not related. Then again, fourth one, where we are talking about complex analysis, interpretation of data and all, we are relating it here. And also, if you see PSO, the program specific outcome, we have mapped it to one program specific outcome, that is the use of modern tools for various computer programs. So, and also for a lifelong learning and for the development of studies. So, here CO8 is mapped to PSO. Now, here we are also having the justification why and how we are trying to map this CO with PO, which we may not discuss in detail. It is just for an understanding what are the number of key competencies that are there. For CO1, there are 3. CO2, there are 3 for PO1 and 4 for PO2. What are the competencies we are trying to understand? Then for CO3, it is mapped to PO1 and PO4. The key competencies are 3 and 2. CO4 is mapped to PO1 and PO2 with key competencies 3 and 4. Then CO5 is mapped only to one PO1, knowledge based, with 3 key competencies. CO6 is mapped to PO1 and PO2. That is knowledge based and also problem solving with key competencies 3 and 4. So this is for CO7, CO8, CO9 and 10. And now what are the number of competences we have seen? We are going to put it in this table. That is for COP. CO1, all the program outcomes. First program outcome is met with all the COs and the key competencies are 3. And in a few cases, CO2, CO4, CO6, CO7 and CO10 are meeting the second program outcome, that is problem solving. And CO3 and CO8 meets the fourth program outcome, that is complex analysis of the problems and conducting investigations. And there is one PSO which is met with CO8. So we are trying to write all the key competencies of these COs with POs. And here we are writing it in terms of percentage. What percentage? See here for CO1, CO2 and all, for the first PO we are writing 100 because there are 3 key competencies and all the 3 competencies are met. So we are writing 100%. And now when it comes to the second one, we have written 4. When there are 10, out of 10, 4 key competencies are being met. So it is 40%. So 40% of key competencies for COs and POs. And then for the fourth one, we have written 2. 2 key competencies are being met in fourth one. So that is 20%. Now when it comes to the PSO, there are 2 key competencies out of which 1 is meeting. So we write it as 50%. So when you see this, what you need to understand is by doing this course, how is it helping in your program? So at the first PO level, which is the basic knowledge requirement that is required for all branches of engineering, is being met. I hope with this you will have a clear knowledge of what course you are doing and how it is helping you in attaining the program outcomes and what is outcome based education. So thank you and see you again in my next lecture.
Like, share and subscribe. Hit the bell icon for more updates.